Today, we are going to begin learning about scientific notation. Our learning goal is that we're going to use numbers expressed in scientific notation, and our success criteria is that we're going to be able to reason with numbers in scientific notation and fluently read numbers in scientific notation. Today's vocabulary consists of 3 words. First, we have our coefficient, which in this case is 3 45/100ths, times a base of 10 and an exponent of 7. So when we look at numbers in scientific notation, we have 3 pieces: a coefficient, a base of 10, and an exponent of any number. We do have a few rules that we must follow when working in scientific notation. To be in proper scientific notation, the coefficient must be greater than or equal to 1, but less than 10. It also must always be multiplied by a power of 10. 2.3 times 10 to the 5th power is in proper scientific notation. We have a number that is greater than or equal to 1, but less than 10. We have a base of 10 raised to an exponent. 45 times 9 to the 6th power is not in proper scientific notation. Today we're going to go ahead and begin in your foldable. Go ahead and open your foldable and look in the top right at the number 57,200,000. This number is in what we call standard notation, the regular way that we write numbers. Today we're going to learn how to change it into scientific notation. We're just going to begin by following the steps. So the first thing I want you to do is put a box around all of your non-zero numbers. In this case, that's going to be 5, 7, and 2. Then we're going to put a new decimal after the first non-zero number. Now I know some of you are thinking, well, I don't see an old decimal. But in whole numbers, it's understood that the decimal is at the furthest right. We don't normally put it, but if you need to put one there to help you, you can. Now we're going to count the spaces from the new decimal to the old decimal. If you count to the right, the exponent is negative, and if you count to the right, the exponent is positive, and if you count to the left, the exponent is negative. Think of it just like a number line. The right side of a number line is positive, and the left side of a number line is negative. So let's go ahead and count those numbers. 1, 2, 3, 4, 5, 6, and 7. Again, from the new decimal to the old decimal, there were 1, 2, 3, 4, 5, 6, and 7 numbers. I'm going to go ahead and drop down the number in my box, 5.72, to make it my new coefficient, times a power of 10. And then since I counted 7 numbers, my exponent is going to be 7. Since from the new decimal to the old decimal, I moved to the right, it's going to be a positive 7. So I get 5.72 times 10 to the 7th power. Let's look at another example. If you look over on the left-hand side, this time we have a very small number that's less than 1, 0.00006211. Let's go ahead and follow our steps again. So go ahead and put a box around your non-zero numbers. In this case, my non-zero numbers are 6, 2, 1, and 1. We're going to go ahead and put our decimal after the first number in the box. And I can go ahead and drop down my new coefficient, 6.211 times 10. This time, I've got my new decimal, and here's my old decimal. So I'm going to count from my new decimal to my old decimal. Basically, I'm counting the numbers in between the two decimals. So this time I get 1, 2, 3, 4, 5, 6, and I counted to the left, so it's going to be negative. So I get 6.211 times 10 to the negative 6th power. Hopefully you notice that the very large numbers end up with a positive exponent and the very small numbers end up with a negative exponent. Now that we've looked at numbers from standard to scientific notation, let's take a look at the bottom portion of your foldable for numbers that are in scientific notation that need to be changed back to standard notation. Step 1 says, write the factor. The factor is another word for the coefficient. So my coefficient is 8.67. It says use the exponent to decide where and how many places to move the decimal. A positive exponent means move to the right, and a negative exponent means move to the left. In this case, I have a negative exponent, so I'm going to move to the left. So I'm going to take this decimal, and it's going to move with me. So the decimal will no longer be here. It's going to move 1 place past the 8, 2 places, 3 places, 4 places, and then I drop my new decimal. Technical difficulties. There we go. So I'm going to go ahead and fill in those 3 empty spaces with zeros. My new number is going to be decimal 0.00867. Notice that my original decimal that was with the 8.67 is no longer there. That decimal literally moved. Think of your decimal as hopping along to the other end. Let's go ahead and try one more together before you try this on your own. This time we have the number 6.2 times 10 to the 5th power. Start by rewriting your coefficient, 6.2. Then the second thing we do is look at our exponent. This time my exponent is 5 and it's positive. Since it's positive, we're going to move to the right. So I'm going to take my decimal and I'm going to move it once, twice, 3 times, 4 times, 5 times, boom, decimal to the right. Again, I'm going to fill in all of those places with a 0. So I moved it 1 place past the 2, but then I still had 2, 3, 4, 5 to go. So my new number is 6, 2, 0, 0, 0, 0. And then I'm going to go ahead and put in my commas. When we put in commas, we start at the far right. We count 3 and then put a comma. 1, 2, 3, comma. So my new number is 620,000. Since we now have a whole number, it's not necessary to write this decimal, but it's not incorrect if you want to go ahead and put it there. Just make sure you place it as a decimal and not a second comma. At this point in the lesson, I would like you to go onto IXL and work on the IXL lesson for changing numbers from scientific notation to standard notation. When you go to IXL, you're going to go in through Student Resources, just like we always do. And once you get to IXL, you're going to go ahead and look for the lesson. In this case, your lesson is going to be Scientific Notation G.1. Scientific Notation G.1. Have a great day and raise your hand if you have any questions.